This is topic 5.2, the first derivative test. So let's just start by taking a look at this graph and see if we can find the critical point. So this graph is just f of x. So we're looking for where the first derivative is equal to 0 or the first derivative is undefined. So let's just start from left to right. The first one I see here is at, what would that be? X equal to 3. And then the next one would be x equal to, looks like we've got another one here. First derivative is 0 there. X equal to 5. And then let's just get rid of these. And then here we have the first derivative equal to 0 here at x equal to 6. Okay, so let's just take a look at each one of those critical points and decide if they are a maximum, if there's a maximum, a minimum, or neither there. One of the things, and I know you can just look at the graph and tell at x equal to 3 we have a relative max. But one thing I want to show you is that all of the slopes of the tangent lines before -3 are positive. So here the first derivative is positive, and after that they are all negative. So what happened was the first derivative changed from positive to negative. So when that first derivative changes from positive to negative, we have a max. So that's sort of where we're headed with this. Of course, on this question, we can just look at the graph. Okay, let's go ahead and look at x equal to 5. We said to the left, the derivative was negative, and if you look to the right of that point, the derivative is positive. So we have a relative minimum at x equal to 5. Now, looking past looking at x equal to 6, to the right of that, all of our slopes are negative. So we have a relative max there because on the left side of 6, they were positive, and on the right side of 6, the slopes of the tangent lines were negative. So that's sort of what we're doing. It's nice to look at the graph. Let's take a peek at these intervals and just talk about this. So if you notice, we could put x equal to 3 right here. And we could put x equal to 5 right here and x equal to 6 right here. And these are the intervals. And I'd really like you to use a sign chart. I'll show you right below that. But some students prefer a chart like this, so we'll just talk about it. Between -∞ and +3, all of our tangent lines, that derivative all the way here is always positive. And then from 3 to 5, so in other words, from here to here, that derivative, first derivative, is negative, okay? And then from 5 to 6, you can see it's positive. And then from 6 to +∞, it's negative. And so that's where we made the notes above, really just reinforcing this. So I'm going to show you how I would make a sign chart and not make this table. So more of a sign chart. So we'll go ahead and write f prime, labeling what we have on this line. And I will go ahead and put those critical points on there. So I would put 3, 5, and 6. And they don't have to be spaced out in any particular order. They don't have to be perfectly spaced. And what we want to do is just find a test value in there. So any number here between -∞ and 3, let's just choose 2. And what we'll do is we'll go look at 2 and see what the derivative is there. And of course it's positive. And then between 3 and 5, we'll just go ahead and pick 4. And at 4, that derivative is negative. Any number between 5 and 6, let's just look at 5.5. That derivative is positive. And anywhere beyond x equal to 6, we see our derivative is negative. So that is the same thing as that table right above. But what I like to do is be able to see that the derivative is positive to the left of 3, negative to the right of 3, so that I know I have a max there. Likewise, negative before 5, positive after 5, we have a min there. Positive before 6, negative after 6. That's why we have a relative max there. So that may help you a little bit. Now let's try this without the graph, and then maybe we could sketch the graph. Again, these graphs aren't perfect when we give these sketches, okay? So let's just go ahead and begin. We're going to be looking for some critical points. Let's go ahead and take our derivative. So f prime of x is equal to 3x squared minus 3x. So we're looking for critical points. So that's where the derivative is equal to 0 and the derivative is undefined. Now, again, we have a polynomial. We have no place that this first derivative is undefined. Let's set this equal to 0. Go ahead and factor while we're here. And we can see that we have x equal to 0 and x equal to 1. So those are our two critical points. Okay, so we have a chart below here, and then I'll go ahead and make a sign chart as well. Let me start with a sign chart. So here's our line. I'm going to put 0 and 1 here. And we can fill in this interval. We're going to be going from negative infinity to 0, 0 to 1, and 1 to infinity. And you can pick any test value you want, and we'll do that up here with the sign chart. This will be the last time I'll use this table, and we'll probably just go straight away and use these sign charts, okay? So we can pick a test value anywhere in here. So I guess why don't we just go ahead and pick x equal to negative 1 and test the derivative there. Now you might be asking, well, what am I plugging this into? Well, that's why I labeled my sign chart as f prime, because this is a chart showing f prime's sign, whether it's positive or negative, okay? So it's really important to label that. But what I like to do is also go ahead and write that derivative down here so I know what I'm plugging these values into. So we have f prime of x is equal to 3x times x minus 1. And I really like the factored form because we don't really care what these function values are. We just want to know, is f prime of x positive or negative? So if you put negative 1 right here in here, so that would be a negative. If you put negative 1 in here, oh my. If you put x equal to negative 1 into this derivative, you're going to have a negative times a negative. And a negative multiplied by a negative is a positive. Okay? So that's what we're going to be doing. Let's find another test value, something between 0 and 1. Let's go ahead and choose x equal to 1/2. Okay? So now, if we put x equal to 1/2, see if I can make this eraser a little bit smaller, my goodness. And just try to get rid of that. There we go. And we're going to go ahead and put 1/2 into both of these. So now we're going to have positive. And put a half in here. 1/2 minus 1 is a negative. And a positive multiplied by a negative is a negative. Okay? So these are really what we're looking for. You probably don't even have to write the other out. Okay? Pick a number anywhere on this interval between 1 to infinity. Let's just choose 2. Could you choose 1,000? Absolutely. Anything on that interval. Plugging a 2 in here, you see a positive and a positive. So we have a positive multiplied by a positive is a positive. So instead of making these charts, I just go ahead and put those values up here. Positive, negative, positive. What is our conclusion? Our conclusion is that the function f, all of this is about f of x. Everything we do is about f of x. We use f prime of x to give us information about f of x. So we can just say f of x is increasing on this interval, f of x is decreasing on this interval, and f of x is increasing on this interval. So you might even think about this function increasing, decreasing, and increasing. So what do you have here? A relative max and a relative min. So that's what we have. Now, justifications are sometimes needed, okay? So we do want to take that time. I'm going to do it right up here. I'm going to write it in blue. And I'm going to say that at x equal to 0 is a relative max since f prime of x changes from positive to negative. X equal to 1 is a relative min since f prime of x changes from negative to positive. Again, even though our sign chart showed us all that, a sentence is required. Okay? So, let's get a little bit more difficult. Actually, we wanted to try to sketch this graph. Let's go ahead and sketch this graph. So when we find critical points, these are actually x values on f of x. We found them using f prime. So let's just find some points on this graph. I don't know, f of 0, that was one of our critical points, is just equal to 2. And let's find our other critical point, f of 1. What would that be? 1 minus 3/2 plus 2. So that would be 3/2. So we would have 1 3/2. So what happens here? What do we say happens? From negative infinity all the way to 0, what's our graph doing? It's increasing. And then from 0 to 1, we said decreasing. And then back up to increasing. Now, I'm going to tell you, these need to be smooth graphs. They have to be smooth. You cannot connect these with lines, straight lines. Everything has to be smooth, okay? These polynomials are continuous and they're differentiable, and so they have to be very, very smooth. So we don't want any choppy, sharp lines, okay? So this is just a sketch. We could go ahead and probably find out where that x-intercept is, but it's better just to have that visual, okay? Let's go ahead and look at this next one. Now, this includes motion. I don't want to get too caught up into it, but we're just going to talk about this particle moving along the x-axis, and we're just going to describe its motion. I'm going to tell you this algebra is going to really be of interest to you. So we're just going to work through it. We have to find the derivative of this function. So we're going to have the chain rule. Take the denominator, square it, and how I do it is I write it right after I square it. Derivative of the numerator minus the numerator times the derivative of the denominator. Everybody has their own way of doing that quotient rule. We have 8t squared plus 8 minus 16t squared all over t squared plus 1 all squared. So we really want a nice, simple, rational expression because we're going to be using it to find critical points. So it looks like we have 8 minus 8t squared all over t squared plus 1 all squared. I think a factored form might be a little nicer. And even better than that, when we use test values, how about 1 minus t, 1 plus t? That difference of squares. Now we have it really, really nice. And there we have it. This is x prime of t. Now remember, our critical points are where the first derivative is equal to 0 and where the first derivative is undefined. Let's look at undefined. Can that ever be equal to 0? Think about that. For the only way this denominator can be equal to 0 is if this equaled -1. Can something squared ever equal -1? No. That denominator will never equal 0. So I'm just going to put this cannot equal 0. So we don't have any place where the derivative is undefined. So let's go ahead and set this numerator equal to 0, 8, 1 minus t, 1 plus t. I told you this would come in really handy, and it did. And here are our critical points. Okay? So this is what I would like to see you do. I would like to see you go straight into a sign chart for f prime of x. Go ahead and make your chart. Put your critical points on there. And now we're going to use test values. And I have this all ready to go. Look how pretty this is. We're going to be putting our test values in here. And the best part is this denominator is always positive. So really all we have to do is look at what the sign of our test values are in the numerator. So if you can notice things like that, that really helps. Pick a number anywhere you want in here. Let's just use -2. Actually, let's use -100. Why? Because we can. So we're going to put -100 in here. So when you do 1 minus a -100, that's going to be positive. 1 plus a -100, that's going to be negative. So we have a positive times a negative, and that's a negative. Now, we don't really want to write all over this. I think because I used a -100, it became a little bit of a mess. But you might have used -2, and that was much easier. Okay, we have a favorite number between -1 and 1. You guessed it, 0. So plugging 0 in here, we have a positive multiplied by a positive, and a positive times a positive is positive. Okay, pick a number, any number we want out here. Whoops. Any number out here that we want. And let's just choose 2 this time. So plugging in a 2 here. 1 minus 2, that's a negative, times a positive, and we have a negative. Okay? So this is the good news. The good news is that, see if I can get rid of that. The good news is that pretty much this sign chart tells us everything. I'll give you a little hint. A student told me a long time ago, we used to say decreasing, increasing, so we knew this was a relative min. And then we'd say we're increasing and decreasing, so we knew we had a relative max. But a student told me that wherever this critical point was, she looked to the left. And if it was a minus, it was a min. So here at x equal to 1, she looked to left, it was a plus, so it was a relative max. So she didn't worry about the increasing and decreasing. Now we're going to have to describe it, but I really liked how she looked left, and whatever that sign was, if it changed, they have to change signs there, then she knew. So I thought that was pretty good. Okay, let's just finalize this because we have to justify. So x equal to -1, there's a relative min since f prime of x changes from negative to positive. And x equal to +1, we said was a relative max since f prime of x changes from positive to negative. You can also say since f prime of x changes from decreasing to increasing or something like that. Now this was a motion problem. So it's really important that we now tell them what was going on at each one of these places. So remember the derivative of x of t, x prime of t, that would give us our velocity, so to speak. So you could think of all of this as the velocity. So we are moving to the left, moving to the right, and moving to the left. And if you wanted to go ahead and write that out on the interval negative infinity to negative 1. Moving to the left. Negative 1 to 1. Moving to the right. And 1 to infinity, moving to the left. That's a whole lot to take in. This was motion, so I feel like that was really important that we recognize that that derivative really is velocity. Okay, let's take a look at using the first derivative test to find relative extrema. Okay, what are relative extrema? Relative max, and relative mins. Okay, let's go find our derivative. It's 2/3 x squared minus 4 to the negative 1/3 multiplied by 2x. Now, what happens is we're left with 4x in the numerator. And note, we have a 3 in the denominator, and we have the cube root of x squared minus 4. There's not much you can do with that. Pretty much this is f prime of x right here. Okay? So, we are looking for critical points. And our critical points are where f prime of x is equal to 0 and f prime of x is undefined. So looking for f prime of x equal to 0, that's that numerator, and we have x equal to 0. Undefined, we have 3 times the cube root of x squared minus 4. X squared minus 4 is equal to 0. X is plus or minus 2. So we actually have 3 critical points. Let's make a sign chart. F prime. Super important to label it because we're actually going to be doing sign charts for the second derivative. And the first derivative talks about increasing and decreasing, and the second derivative is going to talk about concavity. It's going to go from negative 2 to 0 to 2. So we need some test points. So I don't know, let's pick negative 1, and now we're going to go over here. And I'm going to put a negative 1 in that numerator, and that's going to be a negative divided by, put a negative 1 minus 4. That's the cube root of a negative, negative over negative. So a negative divided by a negative is a positive. Okay? Let's just keep going. Any number between, any number between negative 2 and 0, let's just use negative 1. So that's going to be a negative in the numerator, and this negative 1 squared right there is 1 minus 4. That's going to be a negative. So, whoops, I think I made a mistake on this first one. Oops. Right here. Because that was a negative 3. I might have said a negative 1. So that's a negative 3 would leave a negative in the numerator, but this actually would be a positive. Sorry about that. So that's a negative. We just did a negative 1 and showed it was a positive. Okay? Now let's put a 1 in there. Definitely a positive in the numerator, but look, 1 squared minus 4 leaves a negative under that root. So that's a positive divided by a negative, and that's a negative. And if you plug any number beyond 2 in here, you get a positive over a positive, and that's a positive. So just take your time with those test values. The most important thing is this sign chart, okay? So here we go. Let's go ahead and see what we have. We have a relative, you can go ahead and do that here, negative to positive, positive to negative, negative to positive. So we have a min, a relative min, a max, and a min. So let's go ahead and do this. At x equal to negative 2, we have a relative min since f prime of x changes from negative to positive. x equal to 0, we have a relative max since f prime of x changes from positive to negative, and x equal to 2, we have a relative min since f prime of x changes from negative to positive. So that was quite tricky. And this was on its entire domain, by the way. You can take the cube root of anything that you'd like. That's a cube root. So just wanted to mention that. Okay, well, let's take a look at this next problem. Trigonometric function. Sometimes these are trivial, sometimes they're not. Let's go ahead and find our first derivative. And it's 1/2 minus the cosine of x. So we want to know where the first derivative is 0 and where the first derivative is undefined. And the cosine of x is defined everywhere, and 1/2 minus something defined everywhere is defined everywhere. So there's no places that were undefined. So 0 equals 1/2 minus cosine of x. 1/2 equals cosine of x. And so x is equal to, now remember we're on 0 to 2 pi. Let's go ahead and draw our unit circle over here. And the cosine is the x direction, and 1/2 is small. So a positive 1/2, we would be there and there. So this would be pi over 3, and this would be 5 pi over 3. So pi over 3, and x equals 5 pi over 3. These are our critical points. Well, I guess that drew that awful big. Okay, so let's make our sign chart. We have f prime, and here is our chart. Now, whenever I'm in a closed interval, I close this up. 0 to 2 pi. It reminds me not to go to negative infinity and positive infinity. So I'm going to put pi over 3 on here and 5 pi over 3. I'm going to tell you something. Choosing your test values can sometimes be difficult. Pick the easy ones. The easiest test value between pi over 3 and 5 pi over 3 is pi. And the easiest one between 0 and pi over 3, you guessed it, is pi over 6. And how about between 5 pi over 3 and 2 pi? We're almost to 12 pi over 6. So we'll use 11 pi over 6 right in here, okay? So those are our test values. So this is kind of a big deal. I'm going to write f prime of x kind of big down here. And again, we just really want the sign. So I'm going to find f prime of pi over 6, f prime of pi. I just really want the sign of it. And at pi over 6, we have 1/2 minus, and the cosine of pi over 6 is root 3 over 2, and that's definitely negative because root 3 over 2 is bigger than 1/2. So we have a negative, okay? Now let's check out pi. So that would be 1/2 minus a negative 1. Of course, that's going to be positive. And 11 pi over 6, 1/2 minus root 3 over 2, and that's, of course, negative. Okay? So now, what do we have? We have a relative, so we're decreasing and increasing, increasing and decreasing here. So, I don't know if I drew those right. We'll just take a look at those. Increasing, and then increasing and decreasing. That's what I meant to do. So we have a relative min and a relative max. So we have a relative min at x equal to pi over 3 since f prime of x changes from negative to positive. And we have a relative max at x equal to 5 pi over 3 since f prime of x changes from positive to negative. Whew, that's a lot. These are just test values. Okay, let's wrap this up. Enough is enough. Okay, biggie. These are biggies. In fact, whenever anybody tells me I have f prime, sometimes I'll write really big that this is f prime. Okay? It's that important that you remember. Now, this is how I suggest doing these. If you can look at the graph and find these, you're fine. I go right to a sign chart with this information since I'm comfortable with sign charts, and I never look back at these graphs when I'm finished. See if you like it. Okay, if this is f prime and the critical points are where what? Critical points, this is where f prime of x is equal to 0 or f prime of x is undefined. So we're looking for where f prime of x is equal to 0, meaning it's going to cross the x-axis. That's where f prime's value is 0. So we have a -3, a 1, and a 3. And now all we have to do is look at the graph. To the left of -3, the derivatives are all positive. These are all positive values. Between -3 and 1, always negative. All of these are negative y values. Between 1 and 3, positive, and then negative. So now we can say at x equal to -3, we have a relative max. X equal to 1, we have a relative min. And x equal to 3, we have a relative max. Now, you have to give some reasons. So f prime changes from positive to negative. F prime changes from negative to positive. F prime changes from positive to negative. So it's a lot. You have to justify that. Okay, let's do that over here. Same thing. -2, 0, and 2. Okay, now everything up here, those are positive y values, negative, positive, positive. So we have nothing here. I don't mean nothing, but we don't have a max or a min. Why don't we, instead of writing nothing, that's kind of funny, no relative extrema. There's really no extreme at all. Okay, so here we're going from positive to negative, so we have a relative max. Negative to positive, a relative min. Let's knock these out. So at x equal to -2, we have a relative max since f prime of x changes from positive to negative, and that at x equal to 0, we have a relative min since f prime of x changes from negative to positive. And that concludes topic 5.2.